Currently, 42 million people around the world have cancer, and by the time I finish this monologue, 103 more people will have been diagnosed with a big C. On average, a 6-month treatment course costs $27,000, a price that not every patient can afford. The good news is, 1 in 5 of all cancer patients can be treated with cisplatin, one of the cheapest drugs available in the market, being offered at the 10th of the price of other drugs. It works really well for testicular cancer. The problem is, lung and ovarian cancer patients suffer from drug resistance. 7 out of 10 patients initially respond to treatment, but only 1 will be alive after 5 years. Thus, the goal of my research is to uncover the mechanisms that lead to resistance and to find ways of overcoming it. I do this by studying a tiny worm less than a millimeter long. It's called Caenorhabditis elegans, and it's a species of roundworm that's completely harmless to us humans. Since all living things are connected to each other through time, our genes, and those of the roundworms, actually originated from a common ancestor way back in time. This means that many of the genes that we have can also be found in these minuscule worms, and thus we can use them as avatars to simulate human diseases. Many types of cancers are caused by mutations, or changes in the sequence of letters in our DNA that contain the instructions needed for our cells to function. We have 6 billion of these letters, but a change in only one of them can lead to devastating consequences. By taking these mutations in humans and placing them in worms, we can study these changes safely without the need for human experimentation. Once we have replicated these mutations in worms, we give them cisplatin to see whether a change is harmless or whether it leads to drug resistance. You see, cisplatin works by preventing cells from multiplying, and if cells cannot multiply, the tumors, or in this case the organism, cannot grow. We know which of these mutations lead to resistance because in the presence of the drug, worms carrying these mutations grow faster than those who do not have it. We have identified which mutations lead to resistance, and my team and I are now working on finding drugs that can help surmount this resistance. We're doing this not only for the 42 million patients who have cancer now, or for the 103 people who have just been diagnosed as I was delivering this speech, but also for the patients of the future. The fight against cancer is a race against time, and thus we should strive hard to make cancer treatments more effective and more accessible to everyone.